Okay, so today, all right, yesterday we started multiplication of rational numbers, which of course mainly was multiplication of fractions. All right, today we're going to talk about division of rational numbers. Now, majority of today's major work is going to be vocab to be used in the problems, and then when we get to the problems, you're going to see that the problems are just like yesterday's, except there's one little minor thing. I don't know if it's minor, it's pretty major, but something you have to do at the very beginning. All right, so here we go. We do have vocab. All right, so if you haven't gotten it out already, go ahead and grab your binder, green on the left, notes on the right. Eyes up here as soon as you're ready to go. Green on the left, notes on the right. Okay. All right, so two vocab words or vocab phrases. All right, the first one is multiplicative inverse. Everyone? Multiplicative inverse. All right, so here's what the book says it is. Two numbers, I should say numbers, whose product is 1. Two numbers whose product is 1. Okay, so two numbers whose product is 1. That means, of course, you're taking two numbers, multiplying it, and the answer is 1 whole. All right. So in this case with fractions, right? This is what you can write. So for example, 4 times 1/4 is equal to 1. 4 times 1/4 is equal to 1. Okay, you might say, well, wait, what? Well, remember, 4 is the same as 4 over 1. And if you were to multiply the numerators, 4 times 1 is 4. The denominators, 1 times 4 is 4. You'd end up with 4 over 4, which is 1. So by their definition, that's what they're talking about. Now, I do want to spend a couple seconds here showing you this. This is the same as if you take the 4, but look, instead of multiplying, you divide by 4, or 4 over 1. Taking 4 and multiplying by 1/4 is the same as taking 4 and dividing by 4 over 1 to get 1. Okay? I'm going to come back to this. We're going to talk about this next part, and then I want to come back to this really quickly before we get into our lesson, because that's pretty important in this lesson. All right, so here we go. The next word is reciprocal. Everyone? Reciprocal. So this is the multiplicative inverse of a number. So 4 and 1/4. Those are reciprocals of each other. 4 or 4 over 1 and 1 over 4. Why are they reciprocals? Why are they multiplicative inverses? Because like we just said up here, if we multiply them, the product is 1. Okay, now really quickly, going back to this up here, if you still don't understand this, okay, just listen, okay? Think about it this way. If you take, let's say 4 and multiply it or let's say this. Let's say divide by 2. What's 4 divided by 2, guys? 2. Okay. Now, I want to talk about this. This is, what is, I'll just say without writing the problem down, what is 1/2 of 4?
2.
Well, half of 4 is 2, right? You might go, what are you talking about, Mr. Wilkins? Well, here's what I'm talking about. What you just said is this. 1/2 of 4 is 2. What this is 1/2 times 4 equals 2. Now, here's what I want to do. Using a little bit of commutative property, 4 times 1/2 is 2. I just flip those around, you still get the same answer. Okay, just stating hopefully the obvious that you guys all understood this. Okay, but let me write it under here because this is what people don't realize. 4 divided by 2, or 2 over 1, is equal to 2. 4 times 1/2 is equal to 2. Watch. 6 divided by 3 is equal to 2, or 6 divided by 3 over 1 is equal to 2. Okay. 6 times 1/3 is equal to 2. Okay. This one right here, what was in our example? 4 over 1, I guess you'd say, times 1/4 is equal to 1. Okay. 4 divided by 4 over 1, or divided by 4, is equal to 1. I want to point something out. Look at all of these. And this is, of course, what hopefully all of you guys can take a look at and realize there's a pattern here, right?
Yes.
If you multiply by a number, it's the same as dividing by its reciprocal. Multiplying by a number, even if that number is a fraction, dividing by its reciprocal. Multiplying by a number, dividing by its reciprocal. You're going to end up with the same answer no matter what. Okay? Now, obviously, this was discovered years ago, and this is a strategy that's used, and your elementary school teachers refer to it as, many of them anyway, KFC. Now some I know teachers go KCF. It doesn't have quite the ring to it, but it would mean the same thing. Okay. Using this ability, all right, using this ability, this rule, all right, this property in math comes KFC to make you guys know that instead of dividing a fraction, we're going to multiply by its reciprocal. All right, and that's the only difference in today's lesson compared to yesterday's lesson. All right, is once we have our division problem, we're going to turn around, make it into a multiplication, and we're going to solve it. Okay, so with that said, are there any questions on that? All right, so here we go. Let's go ahead and take a look at some examples. All right, so the very first thing we're going to do, let's take a look at 117, problem 20. Okay, now we're going to start, of course, easy like usual. We're going to start fairly easy, and we're going to get a little more challenging. So number 20, and problems like that, if you take a look at the directions, it says, find the multiplicative inverse of each number. So for number 20, we have -4 2/7. Now, step one. Step one is, if it is a mixed number, we're going to change it to an improper fraction first. Okay, you can even put a star by step one because there might be problems on here that you don't have to do this first step. So in this case, right, 7 times 4 is 28, plus 2 is 30, so we end up with a negative, don't forget your negative, -37. Okay? Go ahead and grab another pen. Okay? Step 2. It's talking about the multiplicative inverse, which most of you guys, of course, know as the reciprocal. All right? So all you're doing is you are flipping, oops, messed up. you're flipping the denominator into the numerator, and the numerator becomes the denominator. Because obviously if you multiply both of those out, it would be a positive 1. So it is negative 7/30. Okay, questions on that problem? That's all you're doing. Don't flip that. Okay? Don't flip that. You've got to change it first if it's a mixed number.
So you just make it to an improper fraction and flip it.
If it needs to be made into an improper fraction, you do it. And step 2 is, yep, you flip it for the multiplicative inverse. That's all they're asking on this one. Right? That's what I said. It starts easy. We're getting more challenging in a bit, though. But any other questions on this? I'm going to have you guys try one really quickly. All right, 30 seconds. Go ahead and try problem 18. Go. Bless you. Okay, anyone need more time? Okay, a few more seconds. Again, those of you that are done with that, go ahead and get going on 1 or 2 other problems there. Okay, guys, 30 seconds. Go ahead and share with your neighbor. Go.
I got 849.
Did you get 849? This is great.
Okay, so, all right, number 18, right, was 6 1/8. So, step 1, we just change it to an improper fraction. 48 plus 1 is 49/8. Oops. And we go ahead and write the reciprocal, 8/49. All right, any questions? Okay, let's go ahead then, bless you, let's go to problem 32. Okay, 32 says, find each quotient, write in simplest form. So we have an actual division problem. So I'm actually going to move this guys up to the top here. So 32 is negative 10 3/5 divided by a negative, and they just put parentheses around it, not a big deal, 2 2/5. All right, so here we go. Step 1 is convert the mixed numbers to improper fractions. So we have 50 plus 3 is negative 53/5, 53/5. I bring down my division sign, bless you, and I go ahead and convert this one. 10 plus 2 is 12, so it's a negative 12/5. Step 2. Step 2 is I use the rule of multiplicative inverse and the property you were talking about. Okay? So, I tell you what, because many of you guys are comfortable with this, for note purposes, we'll just call it KFC. All right? So remember, we go ahead and keep the first fraction, negative 53/5. Okay, we're going to flip the second fraction, okay, meaning we're going to write the reciprocal. So negative 5/12. And then we're going to change the sign to multiplication. Okay, sorry, I wrote it incorrectly. It's negative 53/5. Okay, I don't know how many of you guys realize that, but make sure if you wrote thirds, sorry, it's fifths, negative 53/5. Okay, now, step 3, we're just going to label this simplify. Okay, and what simplify means is you can reduce at the end, or because these are such big numbers, it'd probably be a nice thing to reduce now. Now, I want to talk about something right now. I'm going to go ahead and cross-reduce. Okay? 5 and 5, I can reduce each by 5 and make them a 1, right? Now, here's another thing that you'll hear teachers say. I'm going to cross-cancel. And what it means basically is the only difference is that because they become 1s, well, 53 times 1 is 53, right? 1 times 12 is 12. So ultimately, if they're the same numbers, the same products here, or the same numbers that you're multiplying, you're going to go ahead and just cross them out. And what's left, of course, 53 is in the numerator spot, 12 is in the denominator spot. Now, I am going to put a little step star here as a little reminder. Don't forget your signs, guys. We might get so caught up in the KFC part and everything else. We have our integer, our negative, so we have two negatives multiplied together. If they're the same, it's a positive answer. So 53/12. Okay, some people, I know why hands are up, because in elementary school, a lot of your teachers said it is not simplified unless you change it to a mixed number. Okay, that is not necessarily true in this class. All right, as a matter of fact, there'll be many times, especially when there's more of the problem to do, that you don't want to put it into a mixed number. Okay, improper fractions are easier to calculate on a lot of problems for exactly the same reason here. So if you write a mixed number, that's fine. You don't have to do the extra work. Leave it like this if you'd like. The answer key will have this on it when we correct it. Okay, you have enough to worry about as it is. All right, questions? Okay, so here we go. Problem I want you guys to try out. Problem 30. Problem 30. All right, I'll give you 1 minute. Go. Okay, who needs more time? Okay, about 15 more seconds then, guys. Again, those of you that are done, just continue on a different problem. Okay, 30 seconds. Go ahead and turn to your neighbor and share. Go.
I got 3/70. You did that part right, just you need to flip that one.
Thanks.
over 70.
All right. So here's some good conversations. I hear some people helping each other. Okay. I hear some friendly disagreements, and that's okay. So let's check this out. Let's see what, as a class, we have here. All right. So just looking for an answer. We'll take a look at the problem in general right now, but being more specific. But for just answers, okay. C1. Mm-hmm. 3 over 70. 3 70ths. Okay. Agree, disagree. All right. Some disagreements, some agreements. Okay. Anyone brave enough to just what's another answer? Anyone would like to share? 9 over 210. All right. Agree, disagree there. Okay. Okay. Some agreements, some disagreements. All right. Any other answers out there? So are those the two main answers?
Yes.
Okay. Well, let's check this out. Here we go. Okay. So for number 30, right? You had negative 9/10 divided by negative 21. All right. So first step is we're going to change any mixed numbers to improper fractions. Well, the nice part is that's not a mixed number. I'm going to go ahead and keep it as negative 9/10. Now, while this isn't a mixed number, obviously it's a whole number. Make it into an improper fraction. Okay. So step 2 is, of course, now we're going to do KFC. So I'm going to keep the negative 9/10. I'm going to go ahead and flip the second number, meaning I'm going to write the reciprocal there. It's negative 1 over 21, and then I change the sign to multiplication. So I'm already looking. 9 times 1 is 9. 21 times 10 is 210. There would be an answer. However, there's an issue. Okay, this is why cross-reducing or cross-canceling in certain times can help. If I look at 9 and 21, I could divide both by what? 3. 9 divided by 3 is 3. 21 divided by 3 is 7. So now, 3 times 1 is 3. 10 times 7 is 70. Negative times a negative is a positive. So 9, guys, right? That's what it's even hard to see it here, 9 and 21, right, to be able to reduce. If that's going to be hard to see, 9 over 210 is going to be really hard to see that you can reduce it. So it's a little easier to reduce here. So always double check. Okay. One thing I want to make sure, actually 2 things I want to make sure we're careful of. All right, and these are things that pop up. 1, please do not try to do step 1 and step 2 exactly at the same time. I'm sorry. I guess I should say, I'd be right. Step 1 and step 2. So many people try to keep, flip, change, and change it to improper fractions all in one shot, and that something's always forgotten. And then it alters. So please do it at two different times. Okay, it will help your chance of succeeding. And then the second thing is I forgot what the second thing was. So I know, yay. Oh, no, it's not yay, because it's obviously pretty important. I'll remember before the lesson's over. All right. So make sure, guys, you don't do both at the same time. Okay, that is pretty important. All right. Any questions so far on that one? All right. Let's go ahead. So basically, all of you guys did the calculations, right? That's pretty good. Okay. Just don't forget to reduce. All right. Always reduce. All right. So here we go. Let's take a look at problem 38. Problem 38. Now we're getting into the nice advanced stuff, the nitty-gritty. So here we go. It's m divided by np divided by 3m over 2p. All right, watch carefully. Every step I've already taught you is going to work on this. All right, so here we go. Step 1 is change it to improper fractions. Well, we don't have to worry about that on this one. All right, there's no mixed number here. Step 2, KFC. So I'm going to write m over np, and then I'm going to write the reciprocal of the second fraction. So it's 2p over 3m. And now I'm going to multiply. I just did KFC. And now I'm going to go ahead and multiply it out. However, before I do, I'm going to cross-reduce. As a matter of fact, I'm not going to cross-reduce. I'm going to cross-cancel. Kind of like we did up with the 5s. Where are they? Right here. These two integers were the same. Well, variables represent integers. And in the same problem, they'll represent the same integer. You see, n, this is really n times p, and this is 2 times p. Guess what we can cross-cancel?
P.
The p's. Because it is multiplication. N? Absolutely. M here, M here. Cross-cancel. And now we multiply straight across. Blank, or in this case, we'll talk about this in the future, it's really 1. 1 times 2 is 2. N times 3 is, I want you to make sure you put your numbers in front of your variables. 3n. Okay, your numbers always go. These are called coefficients. And again, we'll get to that more later. 3n. I do know the other thing that I was going to tell you guys about. Remember I said there's 2 things that people make mistakes on. Here is, okay, here's the other one, is that people will cross-reduce when it's still division. No, that doesn't work. Okay? Remember, you only cross-reduce during multiplication. So be careful of that. Because look, eventually the 2p ended, if I would have cross-canceled here, the 2p ended up on top. So that won't work. Okay, you can't reduce 2 numerators. Okay? So 2 over 3n. Any questions on that one? All right, try 36. 36, go. Okay, anyone need more time on 36? All right, a few more seconds there. Okay, 30 seconds. Go ahead and turn to your neighbor and share. Go.
I got 5 over 10.
Hold on. Okay, what did we get, guys? 1/4. Now listen, hold on. One little reminder, number 34 today is a word problem. We've talked about, we know you're doing division. Okay, remember the total, a reminder, the total is what you start with. They'll give you the total and then they'll ask you either for groups or the size of groups. So remember that, that's your division problem. All right?